Moving on to the assignment operation, in this stage, we need to add support for assigning values to variables using the equal to operator. We need to only support variables that have already been declared in the environment, and only those variables are supported on the left side of the assignment operator. What this also means is that we are not supporting object fields right now. Let me show you what that means. Let's say there exists a variable a, then we are allowed to assign a value to it. But let's say there is an object and it has a field called field. We are not allowed to update it yet. We will do that later on when we get to classes, but not yet. What we are supporting right now is just this. There exists a variable and we are assigning it a value. But we are also allowed to do this. And you need to remember that an equal to is right associative. What that means is b equal to 1. This expression results in a value of 1. So we can wrap it with braces and assign a to be equal to b equal to 1. And then a will be equal to 1. The value of a will be equal to 1 if we were to print it. Since equal to is right associative, we can actually drop the braces. We don't need them. So this is a correct statement. This works and we need to support it. So right now, as you can see in our context-free grammar, we have an assignment, but it's just going into an equality. It doesn't have the assignment rule. It doesn't state anything right now. As a matter of fact, we do not even do anything with it in our parser. If you were to go to a ternary, our ternary is supposed to go to an assignment, but in our parser, we're going to an equality. In our ternary, we're going to an equality. We need to change that. We need to go to an assignment and we need to write a rule that will satisfy this. So what does the rule look like? The rule states that any assignment must begin with an identifier. So an assignment must be an identifier followed by an equal to. And followed by an equal to, and on the RHS, the right hand side of the equal to, we can have an expression or another assignment. We can have an assignment, and this assignment will later on equate to any of these lower ones. It may be unary, it may be a primary, it may be any of these expressions. But instead of going to an assignment, it can simply go to an equality. So it may not be an assignment at all. Now this is very curious. Why is that? Oh, my bad guys. Sorry, I need to copy it. Oops, equality. Wait. As I was saying, this is very curious. Let me explain this. Why that is. When we come to parsing assignment statements, we actually won't ever know that we are at an assignment until we hit the equal to, because an identifier may just be a primary. So we will know it's an assignment only when we see an equal to preceded on the LHS by an identifier. In that sense, assignment is weird. We don't know we are at an assignment until we see an operator in the middle of it. And this is different from other expressions. It's different from algebraic expressions like a plus b, because a can be an expression and b can be an expression. But that is not the case with an assignment. The LHS of an assignment must necessarily not be an expression, because if it were an expression, our interpreter would evaluate it. That's not what we want. The LHS of the assignment can only be a variable, can only be a token to which we can assign a value. Alright. So that is why when we come to creating assignment nodes for our AST, we won't keep an expression on the LHS, we will only keep a token. And we will know we are at an assignment expression only when we encounter an equal to, and in that case only we will typecast the LHS to be a token, or maybe create a token out of it. So we need to make our parser compliant with this rule. But before that, what does our parser create? Our parser needs to create an assignment, but we do not have that node yet. So let me create that class. And in here, this needs to extend the expression, and I will visitor dot visit assignment. It doesn't exist yet. We will create it, and it needs to have, like I told you, the LHS. It's going to be a token and not an expression, because if it were an expression, our visitor pattern that we have implemented in our interpreter will actually visit the LHS expression and evaluate it to a value. We do not want that. We only want the token, the lexeme that we can fetch from the environment. And by environment, I mean this class that we created and this hash map. So we need a public final token, and let's just call it name, and a public final expression value, and let me create a constructor here. Since we added a visit method to our expression visitor, we need to add it to our AST printer as well. Let's implement it, and let me just copy and paste what it will look like, what a visit expression should look like. I already have it copied, so it's just going to be, I'm just printing the assignment expression as it is. So now we actually get to implementing the parser, the rule in the parser. Like I told you, our ternary is going to an equality, but instead it needs to go to an assignment. And in the assignment, right here, we need to implement this rule. So let's just copy it for reference. Close this class, get here, comment, assignment. So, like I told you, we will only know we are at an assignment when we hit the equal to. Until then, it may just be an equality. All right. And we will typecast the equality to be the LHS when we see the equal to. So let me get the equality out first. So expression LHS equality. This is the LHS. Now we have a method to check an operator. Let's just use it. If match current token to be equal, and if it matches, it moves ahead, it advances. I hope you remember that. See, it advances. So we need to get the token token uh, equal to previous. I'm using this equals to throw. I'll be using this equals. Let me show you where I'll use it. If we have encountered an equal to, then we know we are at an assignment. So let's just get the RHS of the assignment now. RHS is equal to an assignment according to the rule, as you can see right here. And so we have encountered an equal to. There are two conditions that need to meet for an expression to be an assignment expression. The first is that there must be an equal to operator, and the second rule is that the LHS of the equal to must be a variable, and we can check that using the instance of. So if LHS instance of a variable, in that case token name equal to, since it is a variable, let's just typecast it to a variable, LHS, and I can get the token out of it now using dot name. This will be the lexeme, and now I can actually create the object of the assignment class. new assignment. I'll pass it the name and the RHS. The name is the LHS and RHS is the RHS of the assignment. But if this condition fails, if it is not an instance of variable, in that case our parser needs to throw an error because it encountered an equal to, but the LHS was not a token. It was an expression, maybe something else. In that case, we need to throw an error, and we can do that with the report method we created earlier. And this is where we use the equals token because our report method points to a token in the error message. So it gets the line from the token, this line. So that's why we needed to get this equals right here. And let's just say the error is invalid assignment target. Invalid assignment target. And from here I can return the LHS. Why? Because we did not encounter an equal to. In that case, the rule states that it's simply inequality. We already calculated the equality, so let's just return the equality. That's all. That's it for the parser. But now let's come to the interpreter. Let's get to actually evaluating assignments. So we already added it to the interface. Let's add the method, implement methods. This is, yeah. So like I told you, a equal to 1. This evaluates to 1, right? What that means is we can say a equal to b equal to 1. All right. And since b equal to 1 will evaluate to 1, that means a will also be equal to 1. That's what this means. So when we get to actually evaluating an assignment expression, the expression itself will equate to the value on the RHS. So we need to calculate the value of the RHS and return it from here. So object value equal to assignment dot value dot accept this, and here I need to return the value. But before returning, I actually need to store it in the environment because I'm assigning a variable, so I need to override its value in the environment. Can we do that? We do not have a method for it yet. We only have a method that puts a key in the hash map and a method to get the value for a corresponding key from the hash map. But we do not have a method that is checking if a key exists in the hash map. That's what we need to do in an assignment. We need to check whether it exists or not first. So we can do that using a method called, I'll create it, void assign, and this assign method takes a token. Let's just call it name, and it takes an object value. It checks if the value exists in the hash maps. Values dot contains key value. If it does, only in that case do we override it. Instead of value, it should be name dot lexeme. If it does, I will override it. Values dot put name dot lexeme comma value, and I will return. But if it does not exist, in that case I need to throw an error. What kind of error do we throw here? We throw an interpreter exception, as you can see, line number 17. Let's just copy it and update the error message. The error message they want us to throw, let's just keep it same. Let's just say in undefined variable. That seems fine. It's not defined. You're trying to assign to it. Yeah, that's fine. Now coming back to the interpreter, env dot assign. I will assign assignment dot name, and I will assign it a value of value, which we evaluated just now. I think that should be it. Let me get the test that they want us to run. This is the test. Let me update my test.logs and let me run it. See what it does. It should print 1, and it does. So let's try to commit and push it. Forget about that. git add git commit minfam. The stage is let's see if it works. All right, it does work. So we passed this stage, and that's it for this one, and I'll see you in the next video.